Okay, welcome to this video. This is number 5 in our series on AQA Level 2 Further Maths random questions. And the first one is about functions fx and g of x, and we have got to state the range of these functions. So if we look at the first one, we know that x squared, the minimum value can be 0 when x is 0. Otherwise, it's always positive. And if you subtract 7, it means that the function here, f of x, can never be below negative 7. So all we need to say is that f of x is greater than or equal to negative 7. Okay, and that goes up to infinity, but you don't need to say that. You can just say it's greater than negative 7. The range of g of x, well, you see, because this is a straight line, it's of the form y equals minus 3x plus 1, if you like. Okay, what it means is that we can just literally look at the two limits. So when x is, let's just put some working here. So when x is minus 4, okay, g of x is going to be equal to, well, it's going to be 13, because it's going to be 1 take away 3 lots of minus 4. Okay, and when x equals 4, okay, g of x is going to be negative 11. Okay, and because it's a straight line, you can simply say that the answer to the question would be that minus 11 is less than, now it's including, because it's including here, so it's less than and including g of x, which is less than and including 13, which is the highest value. Okay, so that's the range of g of x. And then we solve this equation, 2 lots of f of x equals g of x. So we simply write that as it is really. 2 lots of f of x is 2 lots of x squared minus 7. And that has to equal g of x, which is 1 minus 3x. So basically I'm going to be solving a quadratic. Okay, so I get 2x squared minus 14 equals 1 minus 3x. If I rearrange that, I get 2x squared plus 3x minus 15 equals 0. Don't need to try to factorize it, because it says give your answers to 3 decimal places. So we're expecting to use the formula. And when we do, we get x equals minus 3 plus or minus the square root of b squared, which is 9. I'll put the square root sign. I'll finish that in a minute. 9 minus 4 times 2 times negative 15. Okay, and all of that is over 2 lots of 2, which is 4. Okay, and when you simplify that on the calculator, you get minus 3 plus or minus root 129. Okay, minus 3 plus or minus root 129. Okay, and that's all over 4. So they are the simplified surd solutions, and what we need to do is give them to 3 decimal places. And that comes to x equals negative 3.589 and positive 2.089. Okay, and that's The end of the first question. Next question. A triangle constructed on a set of XY axes. Well, we've got to work out the length of this line PC. Okay, so let me just show that line first of all. So that's what we're looking for, the length of that line. Now, before we do that, we need to know the coordinates of the point P. And we notice that P is 3/4 of the way along this line. Okay, now you could work that out fairly easily, but I'll show you a proper method. Okay, the 3/4 comes from this ratio, you see, 3:1. So I'm going to say that the point P has the following coordinates. Okay, so this is like the coordinates of P. So the x coordinate is going to be 1 plus 3/4 of the distance between 1 and 7, which is 6. So it's going to be 1 plus 3/4 of 7 minus 1. That's how I work it out, you see. And the y coordinate of P is going to be a similar calculation. It's going to be 6 plus 3/4 of the difference between the y coordinates in the same order. So this, I want 1 minus 6, not 6 minus 1. Okay. Now, if you work out the two parts to that, those coordinates, it comes to 11/2 for the x coordinate and 9/4 for the y coordinate. Okay, so the point P has coordinates 11/2 or 5.5 and 9/4 or 2.25. Okay, so to get this length now, we need to use Pythagoras' theorem. So what I'm going to do is just bring this a line down here. Okay, bring a straight line down there, bring a straight line across here. Okay, and the two lengths that I've just drawn in red, well, this is going to be 12 minus 9/4. And this length across here is going to be 9 minus 11/2. Okay. And so I can just use Pythagoras' theorem on that now. So I need 12 minus 9/, so if we say PC squared, so that's the length PC squared, equals 12 minus 9/4 squared, all squared, like that, plus 9 minus 11/2, all squared. Now you've got your calculator, so you can use that. And that comes to 1,717/16. Okay, and then what you need to do is square root that, and that gives you that PC equals 10.63, 10.36 to 4 significant figures. Okay, and that's the answer. Factorize this fully. Well, the first job is to go through the whole thing and take out all common factors that appear in all terms, and that is 6. Okay, it's very easy to go wrong here, so you need to be careful. So the highest common factor is 6. We've got a P, we've got a Q squared, okay, because the lowest power of Q is Q squared in all of them. So we've got P, Q squared, R, okay, because we've got to factorise it fully, you see. If we just put PQR, we wouldn't be fully factorising. And then we just got to work out what's left for each term, and then possibly work on the bracket that we get. Well, let's see if we need to. This is going to be 2Q, okay, because if you multiply 2Q by this, you'll get this. This is going to be 3, and it's just going to be R, okay, and this is just going to be 4, because it's 4 times 6. And that's it. And there's nothing further you can do with that bracket, so that is fully factorised now. Okay. The next one. Now, you could expand all those brackets out. It tells you not to, because it would take ages. There's absolutely no point at all anyway, because the common factor, the highest common factor of, well, first of all, we've got 6 and 4, so it's going to be 2, okay? But we've also got y plus 3 to the power 5 and y plus 3 to the power 4. Well, y plus 3 to the power 4 is a factor of both of those. So we just write y plus 3 to the power of 4 as the common factor, the highest common factor, along with the 2, and see what's left. Well, what's left is we've got another y plus 3 to multiply by, and we've also got a 3. So it's 3 y plus 3, okay, because if you times 3y plus 3 by 2y plus 3 to the 4, you're going to get 6y plus 3 to the power 5, which is this bit here. But we've also got this bit to deal with. Well, we've got 2y plus 3 to the 4 outside. We've now got to make it into 4 of them, so we just need to double it. So that just becomes a 2. And now we simplify this big square bracket, okay, and it will give me 2 lots of y plus 3 to the power 4, okay, multiplied by, and this is going to be 3y plus 9 plus 2, which is 3y plus 11. And that's it. That's the answer, fully factorised. Third one is, well, again, you've got to spot things here. A common factor, first of all, of both terms is actually 3. So the very first thing is to write it as 3 lots of 16 minus 25x squared. And you should notice the difference of 2 squares in that bracket, because 16 and 25x squared are both square numbers, okay, and there's a minus sign between them. So it's 3 times 4 minus 5x times 4 plus 5x. Okay, and you really need to look out for that. This question is a trigonometric question about using sine and cos and tan, as you'll see in a moment. We've got to work out the size of angle x lying between 90 and 180, all right, if this equation is true. Well, the first thing to notice is that you can write that as 8 cos x equals negative 5 sine x. Okay, if you divide both sides by cos x, and you can cross multiply effectively by making 2 fractions, it's the opposite of cross multiplying really, you can see that it follows from that 8 over minus 5 or minus 8 over 5 would be the same as sine x over cos x. Okay, and the reason I've done that, of course, is because sine x over cos x is tan x. Okay, so that implies that tan x is equal to negative 1.6 or negative 8 over 5. And that implies that x equals, if you put that on the calculator, it will come out to give you negative 57.99. All right, x equals negative 57.99, etc. Okay, I think it's 4. And you then need to add 180 onto that, because that isn't in the range, and the tan function repeats every 180 degrees. So I now need to do 180 plus minus 57.99, and that comes to exactly 122, well, not exactly, but 122 degrees to 3 significant figures. Okay, and that's the answer that's in the required range between 90 and 180. So with tan, you just have to remember it repeats every 180 degrees. And when you do inverse tan on the calculator, it will give you the value closest to 0, even if it's a negative answer like it did here. Okay, now this one is another trig identity. Okay, that's what the triple lines there mean. And what you've got to do here, it says you must show you're work out the values of a and b. Well, look, 6 sine squared x is the same as 6 1 minus cos squared x. Okay, because the identity you should know is that sine squared plus cos squared equals 1. Okay, so that's the first step to my working. And that equals 6 minus 6 cos squared x plus 4 cos squared x minus 6 plus 4 is minus 2. So it's 6 minus 2 cos squared x. And that equals a plus b cos squared x, which is what they wanted us to show. And therefore, just to summarize, a equals 6 and b equals negative 2. Okay, and that's what they were looking for there. And that's the last question. We have here, we notice straight away we've got a 9, an 81 and a 27, and they're all powers of 3. When you solve this kind of algebraic index problem, you need to find a common power, a common base for all of these 3 terms. So my first step is to write this as 3 squared to the power of 0.5p, okay, multiplied by 3 to the power 4, and that's equal to 3 cubed 27 to the power of 2p minus 1. Okay, and now they have a common base of 3, you see. So I can say that I've got 3 to the power of 2. Now you multiply those together, don't you? The indices. So 2 times 0.5 is 1. So it's 3 to the power of p times 3 to the power 4 equals 3 to the power of, and it'll be 6p minus 3, because I'm multiplying the 3 by the 2p minus 1, you see. And because I've now got a common base of 3 all the way through. I can apply the rules of indices, where I add the indices when I multiply. So p plus 4 equals 6p minus 3. Solve that equation. Well, I just take p from that side and add 3 to this side. 7 equals 5p. So therefore p would be 7 over 5, or 1.4. Okay, that's the answer. And that's the end of those 5 questions.